guys, let's talk about estimating with fractions. And the I can statement we're working on is I can solve using addition, subtraction, multiplication, and division real-world problems involving rational numbers. Now in this video we're not going to get into the real-world problems portion of this I can statement, but we're definitely going to get into the computations, particularly addition and subtraction, although the concepts we talk about can be applied to multiplication and division of rational numbers. And the rational numbers we're focusing on in this lesson are fractions. So let's consider a number line that's labeled with the points 0, 1/2, and 1. Now, let's list some fractions that are equal to 1/2. So, aside from 1/2, you might be thinking of fractions like 5/10, 10/20, 25/50. And now let's consider some fractions that are slightly more than 1/2. So you might be referring back to this list of 1/2 fractions, or equivalent fractions to 1/2, and you might be thinking fractions like 6/10. It's a little more than 1/2. 11/12, 26/50. Now let's consider some fractions that are slightly less than 1/2. Well, if we're referring to the fractions that are equal to 1/2, we might be thinking of fractions like 4/10, 9/20, 24/50. Let's make some general statements about what we've seen so far, just in reference to the fractions that are 1/2, slightly more than 1/2, or slightly less than 1/2. And some general statements you might be thinking of are, if the numerator is exactly half the size of the denominator, then the fraction equals 1/2. So, for example, 4/8, 4 is exactly half of 8, so that equals 1/2. Some other things you might be thinking about are, if the numerator is slightly more than half the size of the denominator, then the fraction is a little more than 1/2. So if I go back to my first example, 4/8, 4 is half of 8, so that's 1/2. 5 is a little more than 4. So 5/8 is a little greater than 1/2. You may also have thought, if the numerator is slightly less than half the size of the denominator, then the fraction is a little less than 1/2. So, referring back to my original example of 4/8, 3 is a little less than 4. So 3/8 is a little less than 1/2, but it's still really close to 1/2. So if we're estimating a fraction like 3/8, I might round it to 1/2 because it's close. Now let's consider some numbers that are exactly 1. 8/8, 10/10, 15/15. Again, as we're going through this, think of some observations you might be making. And now let's consider some fractions that are just a little less than 1. So you might be thinking of fractions now like 7/8, 9/10, and 14/15. Let's make some general statements about these concepts. Well, if the numerator is exactly the same as the denominator, then that number is exactly 1. So 8/8 equals 1. It's exactly 1. Another general statement you might be making about these concepts in your mind are, if the numerator is a little less than the denominator, then the number is a little less than 1. So, going back to our original example, 8/8, 7 is a little less than 8. So 7/8 is less than 1. But if I'm estimating, I might round 7/8 to 1 because it's really close. Now let's consider some numbers that are exactly 0. 0/12, 0/16, 0/18 are just a few examples. And I'll bet you've already guessed it, we're going to consider some numbers that are a little more than 0 now. Numbers like 1/12, 1/16, and 1/18. And you probably guessed it, we're going to make some general statements about what we've just seen. If a number is, if the numerator is 0, then the number is exactly 0. So 0/12 equals 0. Let's keep in mind the 0/12 for our next general statement. If the numerator is much smaller than the denominator, then the number is a little more than 0. So for example, 1/16. 0/16 is 0. 1 is a little more than 0, so 1/16 is slightly greater than 0. However, if I were estimating this fraction, I might round it to 0 because it's pretty close. So let's do some practice with this. There are going to be 10 problems altogether. The first slide's going to have 4 problems, and then you'll have to pause the video for to complete the 4 problems, then hit play to get the next 6 problems. So, here are your first 4 problems. In each of these problems, you need to describe the approximate location of the given fraction. And it says relative to 0, 1/2, or 1. So if we were estimating and rounding these fractions, would I make each of these fractions 0, 1/2, or 1? So in the work section of your notes, go ahead, write the fraction, then write its approximate location. Okay, now we're going to estimate the sum or difference of the following. And I'm going to go through number 5 with you. You're going to look at each of these fractions or mixed numbers and ask yourself, is it closer to 0, 1/2, or 1? Then you're going to take whatever you round it to and add them together. So 9/10. 9 is very close to 10, so I would round that to 1. 4 is a whole number, so I'm going to leave that, and 5/6. 5 is very close to 6, so I'm going to estimate that and make it 1, but since I've got this 4 in front of it, I'm going to turn 4 and 5/6 into 5, because I've got the whole number of 4 plus my fraction, which I've estimated as 1. For the third mixed number, I'm going to leave the 3 for now and look at 5/12. Well, 6 is half of 12, and 5 is close to 6, so I'm going to estimate 5/12 to 1/2 and leave that whole number 3. Now I need to go and add. 1 plus 5 is 6. Plus 3 is 9, and the only fraction I have is this 1/2, so 9 and 1/2 is my sum, my estimated sum. So pause the video, complete 6 through 10 in the work section of your notes. You can go back and watch any portion of this video as many times as you need to, but don't forget to WSQ in your notes.